Good day, I'm Maile Matsiba. Today we continue with class test 1 of 2011. We're looking at part 3, which is the last part of question 1 of this class test. So it says that nitrogen, which is 42 kilograms, and hydrogen, which is 6 kilograms, are loaded into a batch reactor and heated so that the following reaction takes place. N2 plus 3H2 equals to 2NH3. Now it goes further to give the information that the reactants and products are gaseous, and it says the reactor is tightly sealed so that no gas escapes. Now we answered question A in the previous video. So now we're looking at question B, or the second part, or the second and third part of question B. It says after 1 hour it is found that 1 kilomole of unreacted H2 is left in the reactor. Now calculate the total mass of gases in the reactor. So calculating the total mass of let me just write it down, that the total mass of gases in the reactor So we'll use two factors to actually figure this out. Remember, we are told that the reactants and products are gaseous. That's the first point. So they say the total mass of the gases in the reactor. That tells us that everything, the reactants and the products, are gases. So basically with this, then it gives us that we're actually going to be able to calculate the total mass of the gases, and we'll never have to worry about any solids found, because or any solids in the reactor, because we are told that the reactants and the products are gaseous. And we also need to remember that sometimes you could put in gases, but then the products include also liquids or solids. But in this case, we are told that the reactants and products are gaseous. So that is the first point. The second point says the reactor is tightly sealed so that no gas escapes. This tells us that it's a closed system. So that means that the initial mass that was put in the system is still the initial mass that will be there after the reaction. Why? Because they are telling us that nothing left, because the reactor is tightly sealed. So that means the total mass of the gases in the reactor is the original masses that were loaded in the reactor, which is 42 kilograms nitrogen and 6 kilograms hydrogen. So we can just basically say it's 42 kilograms plus 6 kilograms, and that equals to 48 kilograms. So that is actually the total mass of the gases in the reactor. Now number 2, it says that calculate the degree of completion of the reactor. Let me just write down here that the degree of completion of reaction. So now I just want to write down the equation for the degree of completion of the equation. Can I allow me to actually write? Let me just do this. Allow me just to write it underneath here, because I'll need more space. So the actual equation is that it's the kilomole reacted of the limiting reactant all over the total kilomole of the limiting reactant, all multiplied by 100%. Now with this said, this is actually the equation. The degree of completion depends on the limiting reactant. And if we can recall, when we were calculating the first question, or A, and also Roman figure 1 of B, we had already gathered the information. Remember, we are told here that it is found that 1 kilomole of unreacted H2 is left in the reactor. And in our previous calculations of the same question, we discovered that H2 is actually the limiting reactant. And when we calculated the number of moles of hydrogen put in the reactor, we find that it's actually 3 kilomoles. So that tells us that the total kilomole of the limiting reactant, which has been calculated as hydrogen, is actually 3 kilomole. And another thing is, if we have 3 kilomole of hydrogen, if we have 3 kilomole of the total limiting reaction, which is hydrogen, and we are told that 1 kilomole is left, that tells us that 2 kilomole of hydrogen is reacted. Remember, 6 kilograms of hydrogen is actually 3 kilomole, and we calculated it in the previous questions. But now we are told that out of the 3 kilomole, which was originally put in the batch reactor, 1 kilomole is unreacted, is left unreacted in the reactor after 1 hour. So that tells us that the kilomole that reacted is actually, so the kilomole reacted is actually 2 kilomoles, because that is actually the 3 kilomole, which is originally the 6 kilograms calculated into or converted into kilomole, minus the 1 kilomole that did not react. So all over, now the total kilomole of the limiting reactant is actually 3 kilomole. Like we said, I've just mentioned that 6 kilograms hydrogen, when you calculated it or when you convert it into moles, it gives you 3 kilomoles. So then that gives us 3 kilomole. And you then multiply this by 100%, and that gives you 66.7%. So this is basically the degree of completion of the reaction. It's always important to understand that the degree of completion depends on the limiting reactant, because that is the furthest that the reaction can go. So thank you for your time. Now we are done with the question 1 of class test 1. In my next video, which is part 4, we're going to be looking at question 2 of the same class test. So thank you, and hope to meet you again in our next video.